We've been studying parallelograms for a few days now. Let's take a look at some theorems that are just related to parallel lines. The first one talks about the distance between two parallel lines. So let's take out our ruler and take a look at the distance between a pair of parallel lines. This is a metric ruler, so from here to here we have about 1 centimeter, and it looks like that no matter where I position my ruler, that the distance between these two parallel lines is always the same. So if two lines are parallel, then all points on one line are equidistant from the other line. In other words, the distance between the two parallel lines is always the same thing, or a constant. Let's take a look at a second theorem that talks about three parallel lines cutting off congruent segments on one transversal. So let me get a transversal. And let's say that I wanted to measure the distance between some points along my transversal. And I'm going to line up my ruler to measure the distance between these various points. And so it looks like the distance from my first point to my second point is about 1.2 centimeters. And I'm going to move my ruler along here and measure the distance between the second point and the third point. And that's also about 1.2 centimeters. And between this third point and the fourth point, it's also about 1.2 centimeters. So if three parallel lines are cut off congruent segments on one transversal, they're going to cut off congruent segments on every transversal. In other words, not just this transversal, but any transversal I would draw. Let's say I draw this transversal. And if I was to measure the distance between any two consecutive points between a pair of parallel lines, that because these were congruent, these segments here would also be congruent. So if we cut off congruent segments on one transversal, we're going to cut off congruent segments on any transversal. Now let's take a look at a few other theorems and see if we can get GeoGebra to help us with these. It says a line that contains the midpoint of one side of a triangle and is parallel to the other side passes through the blank of the third side. So let's use GeoGebra to help us out. Let's get a triangle. So here's my triangle, and I want to have a line segment pass through the midpoint of one side of a triangle, and I want that segment to also be parallel to the third side of the triangle. And I need a point of intersection here. And notice that these are connected. So let's think about where this point E is located on segment BC. Let's measure the distance from B to E and from C to E. Notice these lengths are the same. What would that tell us about point E? Let's go back and take a look at the theorem. It says a line that contains the midpoint of one side of a triangle and is parallel to the other side passes through the midpoint of the third side. That seems to make sense. That's what we had going on here. It was through the midpoint here, parallel to the third side. It passed through the midpoint of the other side. Let's take a look at one final theorem. This one says a segment joins the midpoints of two sides of a triangle. Well, that's what I have in my picture here. This segment is joining the midpoints of the two sides of the triangle, and we know that it's parallel to this side. I wonder how the length of DE compares with the length of AC. Let's measure and find out. The length of DE is about 6.64. Well, AC is definitely bigger than 6.64. It's 13.27. I think that it looks like that the relationship here, it looks like AC is twice DE, or we could say DE is half of AC. So let's go back to the theorem one more time. A segment joins the midpoint of two sides of a triangle. The segment is parallel to the third side and half the length of the third side. That makes sense. All right, let's take a look at one final example to finish up. It says x, y, and z are the midpoints of the sides of triangle ABC. It says that AB is 10, so this entire segment here would be 10. And because z is a midpoint, I know that AZ is 5 and BZ is 5. Then we're told that ZY is 4, so that means that this is 4. Well, I know that ZY is supposed to be half the length of the third side of the triangle, so it's going to be half of this length, so this would be 8. And X is a midpoint, so we've got 4 and 4. And then finally we're told that CY is 7, so if CY is 7 and Y is the midpoint of CB, we'd have 7 and 7. And this length XZ would be also 7, because XZ would be half of CB. And the very last segment, XY, I know XY is half of AB. So that I know that XY is 5. And the question here is, what are the perimeters of our two triangles? Well, let's see, the perimeter of my big triangle is 8 plus 14 plus 10. That would be 32 for the big triangle. And for the small inside triangle here, I'd have 7 plus 4, which would be 11, plus 5 more would be 16. It looks like the perimeter of the smaller triangle is half the perimeter of the larger triangle. Well, that makes sense, because each of these sides is half one of the sides of the triangle. Don't forget to do the survey at tinyurl, and we'll be taking a look at more examples in class tomorrow.